Hi, Mark Dingman here again. I'm going to talk about the Stellantis STLA architecture today. And real quick, I guess it's on that side. Daphnis is my gateway for automotive structural consulting. So if you're interested in that, what I can help you with, hit that website and you'll learn a bit more. So the 19th of January, Stellantis released a YouTube video talking about their STLA Large sub-architecture. It's a 1-minute video. There's an enormous amount of information packed in there. And what I've got here, like previous videos, is just some takeaways from an automotive structures perspective. The images that I'm using here, and I'm hoping to have this video up as long as I can. The images I'm using here are from a YouTube video from Ogata on Reviews. That's the source. Somehow they released their video as a Creative Commons license, which means I can take snapshots from that. I don't know how they did it though, because the Stellantis video is not a Creative Commons, but anyway, I'm going to keep this up as long as I can because it's a lot easier talking around pictures than drawing things and hand waving. So why do I think Stellantis architecture is really interesting? They are nearly opposite in their strategic approach as Tesla is. And a lot of traditional OEMs are doing the same thing, but Stellantis is really out on the edge of this architectural strategy. So what I mean by that, well, let's look at a couple things. The cost strategy. Tesla seems to have an unlimited amount of money that they can throw at manufacturing tooling and the manufacturing process and building new plants. And they're doing this to minimize the product price. And, you know, the large castings is a good example. They spent a lot of capital to execute that in order to what they're thinking is to save some piece price in the product. Whereas Stellantis and a lot of traditional OEMs are looking at more of a balanced or minimized investment cost strategy. We're trying not to spend so much money on the manufacturing process and the tooling, and they're willing to incur some level of product price scar in the product that they sell. Now, on the architectural variant strategy, so how many different vehicles are you building off of this platform? Tesla has a very narrow variant bandwidth strategy that they're executing. As the bandwidth gets wider, you traditionally incur more scar on the product in terms of price and mass. So Tesla is so focused on minimizing the piece price of the product that they have a narrow variant bandwidth strategy that they execute. S and X, they brought those two together recently. Shared a lot more underbody components with those two. Certainly the 3 and the Y, right? But as they develop new things, they're not widening this architectural underbody bandwidth. Stellantis here has, call it one high-level architectural strategy, and they have some sub-architectures in there to minimize the bandwidth, the scar incurred by the bandwidth. But certainly they have a much wider bandwidth and flexibility within the architecture. Interesting, right? I love it. So let's get into the STLA. Hopefully I'm saying that right and get the words in the right order, letters in the right order. What did we see in that 1 minute and 5 second video? First thing, and I love this too, right? There's a propulsion flexible architecture. This is not the first company that's doing this, but to not only have a variant flexible strategy in your EVs where you can make cars longer and wider and taller, this is a strategy where they can offer BEVs, plug-in hybrids, and gas engines in the same architecture. Yeah, some manufacturers have to change out, say, the rear compartment panel. Some are changing out the center compartment. But this is a strategy that, again, minimizes the investment, minimizes the number of parts, but maximizes the number of products that you can build in this kind of Taco Bell strategy. Other companies for sure have done this and are executing this now. For example, there's at least one European manufacturer that is doing a propulsion flexible architecture. And I mean, they're able to flex production 100% between battery electric and gas. So this is an interesting strategy when the future is uncertain about the market and the product mix that the market's going to demand. Is it going to be 100% EV? Is it going to be 30% EV like the Toyota execs are saying now? This hedges the bets for sure. Like everything else, this incurs a little mass and cost scar into the product as you expand the flexibility and bandwidth of the product. Yes, I got everything here. So next one, scalable platform. This is again the flexible strategy in the underbody. So they're saying they can flex wheelbase, front overhang, rear overhang, through body white assemblies and shim assemblies. I say shim assemblies if you're I'll say Stellantis knows how to do this for sure. Part of Stellantis was PSA before a merger, and they, in my mind, they were very good at executing this stuff. It maximizes reuse, keeps the cost down on the production side and the investment side. So hopefully there's not a lot of scar mass and cost that's involved in this. And this was the large sub-platform, and they're saying they can do a lot of different things here: passenger car, crossover, off-road, blah blah blah. Right? Lots of flexibility. I'm calling this one unique side structure, and this is unique really from the perspective of an engineering solution application. It's very typical for a BV head to have an energy absorption member and force distribution member in the rocker system. Because of one load case in particular, side pole. This one's unique in that it really looks like a discretely attached steel tube, which is not a new engineering solution. In fact, there's one manufacturer out there that really enjoys applying this to other parts of the car, but I don't believe I've seen it here. I played around with this engineering solution in the past, and there certainly there is a challenge with respect to distributing force in a member that's discretely attached. So this will be interesting for sure. See how this works out for them. It's very likely a cost advantage over an aluminum extrusion, but it's the details are going to fall out, and I'd love to see how this works in crash. So material strategy of this architecture, the body certainly looks like it's certainly sheet metal. There are no cast corner structures here, or gigacast or megacast and shock towers and wheelhouses. It looks certainly sheet metal dominant. It does look to be steel, if I had to take a guess based on the geometry of some of these parts. And I'm just going to throw it out there that they're going to be cost focused on this product, so I'm going to guess that as well. Front cradle looked to be sheet metal as well. I think that I've got another slide on the front cradle. We'll get into that a little bit later. And the rear cradle looked to be a hollow cast aluminum. Yeah. So here's the front cradle slide. Maybe a little harsh, but this doesn't. To me, this does not look like, to be a state-of-the-art front cradle topology with respect to the IHS shallow small overlap frontal load case. Yeah, I'm given a little leeway here, but it looks, there's eight primary interfaces to the body, and then there's one off in the corner there that I'm kind of discounting, but typically today in this size vehicle, you have a 6-point front cradle. So it looks like there's some engineering opportunity here. Again, they developed the car. They know more than me, but this is not going to be at the cost and mass level of say a Tesla Model 3, Model Y, for what I see here. The material, it's hard to tell if this is aluminum based or steel, but some of the picture, if I had to guess, I'm gonna guess steel based off some of the pictures, but really hard to say. Front suspension. Wow, another challenge here. This is a forward-facing lower control arm. This is a challenge for, I'll say, one very significant load case that the body and the battery have to develop around. It's a multi-link. It has upper control arm, but the lower control arm is forward-facing. So again, if you worked with me, you know what the challenges of this are and what this means. Won't get into it here. Rear suspension. It's funny, the initial animation of putting the car together, I couldn't find the rear shock, but later in the 1-minute video, there was a picture of the rear shock, and they did get the rear shock under the rear rail, so good job there. They lucked out, or they did that intentionally and put some pressure on the drive unit size, so that's going to help them out for efficiency. So digging deep into the takeaways for sure at this point, I found it interesting that Stellantis talked about Driveline Flex, and we're talking about front-wheel drive, rear-wheel drive, and all-wheel drive. And I say it from the perspective that in the BEV world, I don't know that I've seen a product that offers all three. Usually it's front and all-wheel drive or rear and all-wheel drive, but not front and rear. I suspect that the gas variants are going to help create this bandwidth they're showing here. But certainly, if they're doing all three, it's a lot of pain to do that. You got to ask yourself why in a BEV. But if they do, I think it will be unique, and we'll see if it has any advantage to them in the marketplace. So yeah, and that's it. I almost feel like I need to give this thing a mark score or a tug score. I've said it through here that I think this strategy is fascinating in terms of the flexibility and the bandwidth that they're capturing here. I'm really interested to see how that translates into, say, financial success and sales success. I love it. I think in terms of structural engineering execution, I think they've got a little bit of opportunity to improve efficiency here in this design. I'd be really surprised if this is as light and inexpensive as some of the competitors and certainly the Tesla products. So there you go. That's my 2 cents on what little we know about this right now. Again, Dafnis is my gateway for automotive structural consulting. So again, if you're interested in what I can do and how I might help you out, head over to that website. And beyond that, happy YouTubing, and let's keep learning about these cars. Take care.